part we are going to discuss with one more problem by using two-phase simplex method. So let me read the problem here. So example number 3. So this is example number 3. Fine. In this example, solve the following LPP by two-phase simplex method. Right? By two-phase simplex method. That is, max z is equal to 5x1 minus 4x2 plus 3x3 subjected to constraints 2x1 plus x2 minus 6x3 is equal to 20, followed by 6x1 plus 5x2 plus 10x3 is less than or equal to 76. 8x1 minus 3x2 plus 6x3 is less than or equal to, whereas x1 comma x2 comma x3 are greater than or equal to 0. So this is what the problem, and we need to solve this problem by using two-phase simplex method. Fine. But looking into this LPP, we can judge that this LPP is not in a standard form. Fine. Not only in standard form, one of the constraints is subjected to equal to constraint. Fine. So what we are supposed to do? First of all, we have to make this LPP into standard LPP. To make this LPP into a standard LPP, we are supposed to introduce slack or surplus variables and artificial variables. So when we are supposed to solve this LPP by using two-phase simplex method, our first task is to construct the auxiliary LPP. Our first task is to construct the auxiliary LPP. Fine. So solution introducing slack variables. The question arises here, why we are supposed to introduce slack variables here. The reason why is that two of the constraints are subjected to less than or equal to these two constraints. Because of these two constraints, we are supposed to introduce slack variables S1, S2, which are greater than or equal to 0, and an artificial variable A1, which is greater than or equal to 0 in the constraints of given LPP, The problem is reformulated as follows. So I have told you why we are supposed to introduce slack variables, because these two constraints are subjected to less than or equal to. And the reason why we are supposed to introduce artificial variable is because this constraint is subjected to equal to. That's why we are supposed to introduce slack variables and also an artificial variable. So once we do this one, we go to the phase 1 here. So what happens in phase 1? Assigning cost minus 1 to the artificial variable A1 and cost 0 to the other variables in the objective function. So what happens when we do this? We will get auxiliary LPP. That is max z star is equal to 0x1, 0x2, 0x3 plus 0s1 plus 0s2 minus 1a1. This is what? Objective function of an auxiliary LPP. Subjected to constraints 2x1 plus x2, find minus 6x3 plus a1 is equal to 20, followed by 6x1 plus 5 x2 plus 10 x3 plus s1 is equal to 76. Then followed by 8x1 minus 3x2 plus 6x3 plus s2 is equal to 50, followed by x1 comma x2 comma x3 comma s1 comma s2 comma a1 are all greater than or equal to 0. Fine. So this is what auxiliary LPP. Madam, some time check this is called as auxiliary auxiliary LPP. Well, once we got the auxiliary LPP, we need to implement this auxiliary LPP in a simplex table. So write all the values, these values in the simplex table. So let me draw the simplex table here. That is CB, then B, followed by XB, then X1, X2, X3, S1, S2, and I will take first, let me write the artificial variable A, then S1, then S2, then it is minimum of XB upon X. This is what? The big table. This example has very big table. So as soon as you get the problem, first of all, see it out how the constraints are subjected to. Whether the constraints are subjected to less than or equal to, or greater than or equal to, or equal to. So depending upon that, you are supposed to solve the problem here. Fine. So better always draw big tables so that you can write the values correctly. Otherwise, if the table is small, you have to write very small letters. Then it will be a confusion for the when you are shifting from one simplex table to another simplex table. So let me write the value. This is Zj minus Cj. This is Zj. So let me write all the values of this table. So what are the Cj values? Cj values are 0, 0, 0, followed by this is -1 and 0 and 0. This is fine. So the bases, what are the bases? That is first one A1 followed by S1 followed by S2. The coefficient of A1 is -1, coefficient of S1 is 0 and S2 is 0. Fine. So what are the values of XB here? XB values are 20, next 76, I think 50 is the next. Then what are the values of X1, X2, X2? That is 2, 1, -6 followed by 1, 0, 0. Next one is 6, 5, 10, 0, 1, 0 it is. Followed by 8, -3, 6, 0, 0, 1. Fine. So once we got all the values filled up, we need to calculate Z value. Fine. That will be explained in the next session.